currently live in San Francisco. It's been 5 years that I live there. My past experience, I used to work for 2 years. I used to work for Twitter. And in the last 2, I decided to start my own startup. My startup is a collaboration software named Plan. As much as you can see from this GIF is a collaboration software where on the right side there is the calendar app, and on the left there are all your tasks. You can drag them inside your calendar. You can allocate your time to decide to not only organize your meetings, but also organize when you want to work on a specific task. I started this startup that we were just in 2, me and another guy from New York. Now we are 6, and some of the things that I love most doing in my startup is focusing on performance. Fun fact, this is my second time in Codemotion. The first time was in 2011. I believe it was the first edition. And I was still a student in the University of Perugia, and I came here. The Codemotion was actually free. I think it was still more than 1,000 people in 1 or 2 days. And at that time, I was mostly focused on Python. But yeah, it's kind of hilarious coming back after 7 years. Everything I'm going to talk today is, I wrote 2 articles. One is First Contentful Paint with a Touch of Perfume, and the second is Time to Interactive with RAM. And these 2 articles, you can find them on my Medium. Both my Medium and my Twitter handle, they are on the bottom. So everything I'm going to talk about in the next 20, 30 minutes, you can find written down and with all the examples in this article if you want to read them later. So let's talk about the experience of visiting a web page. So when you visit a web page, there are 4 key moments that define visiting a web page. Is it happening? Is it useful? It is usable, and is delightful. These 4 key moments, we can see it across the performance timeline, where we have the first paint, the first contentful paint, first meaningful paint, a time to interactive. And the last one is delightful, is actually after the time to interactive. Right now, during the talk, we're going to focus on first paint, first contentful paint, time to interactive, and the part after. All these performance metrics that I'm going to talk about are actually still in draft. So I think the draft name is Performance Timeline Level 2. That is still a work in progress. And the first 2 that I want to talk about is the difference between the first paint and the first contentful paint. So the first paint, in a very simple way, is you write the name of the website and you see a white screen. From the moment that the background goes from white to any different color, that moment is the first paint. As soon the browser is going to render any small type of content. That can be a title, that can be an image, an SVG. That instead is the first contentful paint. So when we say we measure them, a post? Okay. So when we say we measure them by using RAM, definitely we are not talking about parting. RAM stands for real user measurement, where real user measurement means that you can actually start collecting field data. So these field data, you can collect them by different web API that are available in multiple browsers. You can get real user experience. So the difference is not that you only calculated the metrics on your laptop. You actually collect through all your users. And that means you can collect information with people that have different cache system, different devices, different network. And collecting this data enables you to actually find what are the conversion, what are the business key performance indicator to understand if anything you write, anything that you try to improve the performance of your web page is actually improving your business. 2 weeks ago, I was to this conference in Redwood City where there was this amazing talk from this e-commerce. I think it's named Etsy, and they were showing how every megabyte they were reducing the bundle size of the first initial loading, they were saving millions of dollars. And not only saving, the conversion rate of people stay on the website and buy more product was increasing. So it's very interesting to see that these metrics, if you start collecting them and you start to studying them, you can actually understand how you can improve your business by improving these metrics. The opposite of RAM, or real user measurement, it's the synthetic measurement. Synthetic is probably the most famous one, the one that actually you probably do it every day. They are easy to measure because they're already on your laptop. So when we talk about dev tools, your profiler, Lighthouse, these are the synthetic. They are the lab data. And we probably already know them. They're easy to measure. You can catch a possible issue before you deploy your code in production. And you have the ability to actually debug your code and understand very carefully where is the problem. With Lighthouse, you can already measure first paint, first contentful paint, a time to interactive on your laptop. And also, Lighthouse gives you the opportunity to kind of test with different CPU level, different cache, and okay, maybe in 4G or in 3G, this is the possible scenario. But we are still in a lab data. We are still, your laptop try to recreate a possible scenario. It's not that you are testing with the real world. So again, synthetic lab is what we're already probably doing every day. And on top of that, to complete the full picture, we have to remember to start using collecting the field data. To collecting this data, there are a few new APIs that are part of the web performance APIs. And the one that we're going to start with is the Performance Observer interface. Let's see. Here we go. So the Performance Observer, pretty straightforward. You have an object. You do an instance of this object. And with this instance, you start observing different entry type. The entry type you can observe with this instance are the paint, resources, measures, and I think the last one is long task. The one we're going to focus right now is the entry type paint. What I'm doing right now, I'm just writing this code on my page and says, please observe the paint type. What is going to return is going to return a performance entry object. In this case, it's named performance entry list. And you do performance entry list dot get entries. You get all the performance entry. And let's see how this is going to look, this type of object. These are the two scenarios. You have the first paint and the first contentful paint. And the part that we are interested is the start time. So let's see very quickly in practice how we can really just right now taking this performance observer and using it on our website. So what you're going to do, we have just a simple page where on top of the page we have the performance observer. On purpose, I change the background to show you the moment where there is the first paint, where the page goes from background white to background, I think this one is yellow. And I try to emulate a single page up where a single page up doesn't load immediately. Probably is going to take half second. In this case, I'm waiting 600 milliseconds, and I'm just creating an H1, adding some content, and appending to the body. There we go. OK, so this is the example that we just seen on the slide. And I'm going to try to make it bigger. So now I'm going to refresh the page and pay attention on the background. As soon as the background goes from white to yellow, we're going to see a new metric coming up. And when the H1 is going to appear, the second metric is going to show up. So we refresh the page. Let's see, white, yellow, H1. And here we have the first paint that is 500 milliseconds. And the first contentful paint that is 1 second. OK, moving on. On top of this, I wanna start using a library that I wrote recently. This library is named Perfume. And the focus of Perfume is making sure that I can use this kind of like experimental web API, because most of them are actually not enabled in all the browser. So I want to make sure if I use this API that are still in a draft, in a W3C draft proposal, I can use them without breaking my website. So this is the name of the library. I started writing early in January. You can find on GitHub. The documentation is pretty straightforward. It's gonna show you like all the different scenarios. And on GitHub, you can like take the codes, open pull request, and kind of like possibly like help me to improve it. So in this case, using Perfume, I'm gonna put the Perfume on top of the web page. And the only thing that changed is I removed the performance observer, because the performance observer now is actually inside the library. And I'm just going to say to Perfume, calculate the first paint, first contentful paint, and please take all this information and upload on Google Analytics. So that's actually an extra thing the library is going to do for you for free. So we're going to see the live Perfume. And so now we're going to refresh. And again, change the background and H1. And now it's just going to print like 1 second, 1.8. And it's just saying that because we don't have Google Analytics in this page is kind of complaining about it. But the cool part, if you have the global variable GA that usually you use on your website, automatically it's going to catch that variable and start like uploading your data. So Performance Observer with the entry type paint works only on Chrome. Safari doesn't work. Firefox, still the latest one, doesn't work. I spoke with the guys at Mozilla, and they literally told me, because it's a draft, we don't want to spend time on it. As soon as it's going to kind of like move on and be more standardized, we're going to like fix it. But because it's still a draft, we don't want to spend time to implement something that might going to change in 2-3 months. Chrome, they don't care. They just implement everything. But at least the library is going to, try to make sure that if you use it, the website doesn't break. We're going to skip the useful part, where is the part related to the FMP, first meaningful paint. And that part, even the people that try to write this metric, they said it's too hard to standardize. They didn't get to the point that is kind of like fully standardized across all the website. So they like focus more on time to interactive. Time to interactive is the moment of is it usable? What I'm saying with this usable is, you open the website, something happened, you're like, okay, this is happening. And you actually can start using the website. It's not like frozen. The official explanation of time to interactive says it's defined as the point at which the layout has stabilized and the key fonts are visible and the main thread is available enough to handle user input. Okay, let's understand what actually is going on. You have your main thread. You open DevTools. You see that many times. And let's understand the difference between short task and long task. Long tasks are actually every type of task that is taking more than 50 milliseconds. Short task, instead, everything that is less than 50 milliseconds. It's important to understand this difference because long tasks are one of the key factors to calculate the time to interactive. The reason is so important, the time to interactive and the long task, is because of this guideline. So the RAID guideline pretty much says that respond to the user action within 100 milliseconds, a user feels like the result is immediate. So RAIL stands for response, animation, idle, load. And that means when you use a web page, everything that you try to do and is more than 100 milliseconds is going to feel a delay. It's going to feel slow. They actually made a study that if you do an action, every type of action in the web page, and takes more than 1 second, your focus goes from active to passive. And every time the user goes to a passive, the user tend to kind of like just change his focus. There was a case where on Amazon, if you have like a shirt and you want to see different color, if it takes more than a second to see a different color, I'm gonna just go from active to passive. I'm like, okay, maybe I should check Twitter, I should check Facebook, maybe I should do something else. So it's very important to keep the user always in an active state so you can keep following the experience. But that is the extreme case, the 1 second. To have like to have kind of like a good feeling of like your user experience, they recommend to keep everything under 100 milliseconds, and I think for touch device is 16 milliseconds. So time to interactive. Time to interactive, to calculate these metrics, the first thing we do is understand where is the document content load. In this image, you see as DCL. You see some like short task, a long task. The long tasks are the orange one. The second thing we do is we take the DCL and we look forward till we find a 5-second network quiet window. So the network, it's quiet for 5 seconds. As soon as we find this window, we look backward. We look backward till the moment there is the last long task. And when you see that red line, that is the last long task, and that is the moment of time to interactive. So as you kind of understand, there are a few cases where we have to understand how to use the time to interactive. The first one is if the document content load up, so the DCL happened after the time to interactive, the DCL became the time to interactive. The second is you cannot use the first meaningful paint because I said before you can't use it as a DCL, as a lower bound, because it's not standardized yet. The third thing is you have to wait. Like the first paint and first content paint, as soon they are kind of like ready in an asynchronous way, you're going to get the result immediately. The TTI is not going to be like that. You have to actually wait this extra 5 seconds to find this white window, and after that, you can understand when actually happened the TTI. So yeah, you have to wait at least 5 seconds, and TTI is not a metric that usually is useful for every page. Like if we talk about a blog post, probably first paint, first contentful paint are the most useful. TTI is probably for a single page app where, in my case, I have a calendar app and I have to like wait that all your data are available and you can actually start using the application, or like Facebook or YouTube. So definitely if you have a small page, don't even try. How we can calculate the TTI? So we saw the TTI, you can calculate with Lighthouse. You just open Lighthouse and you have all the results ready. How we can calculate the TTI in a field data across all my users. So they wrote this polyfill, just named TTI polyfill. And back into the old example, the polyfill works in 2 steps. The first step is having a performance observer on the top, where, as you can see, we are watching as an entry type long task. So if you actually see this part, this is not anymore entry type paint, it's entry type long task. So what we do in this case instead, we just add some button. We try to recreate a situation that every time I do a +1, I try volunteering, like on purpose, I'm trying to freeze the application. And the way I froze the application is by, let's see, I'm actually going to show you in the demo, but the way I use the TTI polyfill is just I take the polyfill and use the method that it's surfaced, and as soon as the TTI is available, it's just going to return as a promise. So in the demo, I just want to let you show this part of the code is the kind of like the part of the code that I'm trying to make the application kind of like froze. So what I do is just like I do a query selector to a specific location, and I do a DOM manipulation for over 40,000 iterations. And the reason I do that, I try in purpose to freeze the application for like at least 3 seconds. So let's see in practice. Refreshing the app. I'm going to try to click the +1. Here, I'm clicking many times, nothing happened. But as soon as this long task that was taking the main thread is kind of like available, you're going to be rendered the number 9. So now if I click, everything is available. The TTI is 3.8 seconds. So again, try to refresh. I'm loading my app. I try to do something. It's frozen. And here we go. It's waiting the 5 seconds, and as soon as it's done, it's going to say, OK, the long task was at 3.4. Same thing. We're going to do it by using Perfume. I love that GIF. And way much simpler. So you just put Perfume on the top, and you just say to Perfume, time to interactive true, so please give me back the time to interactive, and put all the information to Google Analytics. And if I go here, so this is the Perfume version, and if I open the inspect element, I refresh, and I try to click here. That actually was too fast. I'm going to refresh again, sorry. OK, clicking, it's froze. It's 10, clicking, now works. But we have to wait the 5 seconds. As soon as it's done, we have the time to interactive back. And so yeah. Moving on, that was the it is useful part. The last part I want to talk today is it is delightful. And how it is delightful works is the moment where, OK, the page is loaded. I can actually use the website, but that doesn't mean that my full experience is going to be delightful. It's going to be like responsive and quick. The way we can calculate that is by using the performance.mark. That has been available for quite a long time. You can that actually it's cross-browser compatible. And the way it works, you can take a mark from one point to another and start measuring that timing. The extra thing is on some browsers like Chrome and I think Firefox, you can actually annotate this information in the dev tools. And that's kind of like a few things that people don't know about it that is very cool. So in the user timing, I actually can annotate a Fibonacci method that took me 0.14 milliseconds. And I can just say, OK, start measuring Fibonacci, do the method, end it, and I can actually show the annotation. And it's very interesting to show the annotation because when you do a bunch of them, you can see inside the main thread when this thing they happen, and it's actually easier for you to do debugging. Moving on, you can use the same technique for components. There are libraries like React that you kind of like get it for free in some version. I don't know if it's still there in the 16. With other browser, with other framework, or even like your jQuery project, if you use still jQuery, you can actually do something like perfume.start, toggle popover, and every time you toggle the popover, you make sure to understand how long it took it. OK, this is a very base thing, like that's not a big deal. But on personal experience, I got to a situation where in the calendar, I had a popover. I have to click to an event, and when I click to an event, show up something. And that usually should take 30 or 40 milliseconds. But because accidentally I didn't notice that the autocomplete library that was inside the popover was every time destroying and initiating, I was wasting resources, in a few words. That library was costing me 150 milliseconds. So bringing that click from 30 milliseconds to over 180. And as I told you already, everything that goes over 100 milliseconds, you can start feel it. You can feel there is a small delay. It's not fast. So that's using perfume.start and perfume.endpoint. You get to the situation where you can actually measure from your click till the first painting. You know, maybe the toggle is actually over way before the paint, but it doesn't matter because the user cared only about the when actually the component is rendered. That is the reason these are user-centric metric. They are focused on what the user is actually feels like when it's using the application. I don't care if the component takes only 10 milliseconds. If there are other long tasks that actually makes the paint happen after 300 milliseconds, that's still bad, and I have to figure out how to fix it. So it's important actually end the measuring at the first painting time. And as I kind of like told you before, all these metrics with Perfume, automatically you can upload it to Google Analytics. And not only you can say the first paint, first contentful paint, Fibonacci, temperature interactive, sorry. You can see the seconds and milliseconds took for each metric. You can actually say, I'm going to add a specific variable. So I'm going to make sure that for each metric, I attach maybe the ID of the user or the email of the user. So I can understand for that specific user with that specific experience, it's taking 30 milliseconds. For this other one, it's taking 200 milliseconds. So I can take the information of the user, say, okay, what's going on with that user? What's the cache system? What is his device? Why is something broke for that experience? So you can actually understand, okay, maybe 80% of my user base works well, but there is the 20% that I have to investigate more. So that's the reason the field data give you the other side of the coin where you can actually understand the full experience of your performance. And said this, it's time that you can actually start playing with this toy. You can play with the official APIs, the Web Performance API. You can use Perfume. But either way, they are very interesting to play for small toy or in production to not only improving little part of your application, but if you do your work right, you can actually keep tracking this information quarter by quarter by quarter and understand the conversion rate. Understand if these metrics, they are crucial for your e-commerce or your application to actually save money or make more money. And last thing, I print out these cool stickers where this actually wrote Perf Matters. And if you just want them, after the talk, I can give it to you. And thank you.